Audiobook Academy Biography presents Louis Pasteur. French chemist and microbiologist Louis Pasteur, December 27, 1822, Dole, France, September 28, 1895, St. Cloud, was one of the most significant founders of medical microbiology. It is practically impossible to compare Pasteur's contributions to science, technology, and medicine to anyone else's. Discovered that germs cause fermentation and disease, invented the process of pasteurization, rescued the beer, wine, and silk industries in France, and created vaccinations against anthrax and rabies, among many other accomplishments. He was awarded France's most prestigious honor, the Legion of Honor, for his contributions to science, and he was also elected to the Académie des Sciences and several other honors. It is an honor bestowed on few scientists that his name is now associated with more than 30 different institutions, including hospitals, schools, buildings, and streets. Early years. During the Napoleonic Wars, Pasteur's father, Jean-Joseph Pasteur, a tanner and sergeant major, received the Legion of Honor. As a child, Pasteur may have been indoctrinated with a strong sense of patriotism because of this circumstance. In his early years, Louis Pasteur was an ordinary student, but he was excellent in the arts. They were then displayed in the Pasteur Institute Museum in Paris, where they had been stored since they were made when he was just 15 years old. After completing his elementary education at Arbois, where his family had relocated, and his secondary education in nearby Besançon, he graduated from the Royal College of Besançon with a Bachelor of Arts, 1840, and a Bachelor of Science, 1842. Research career. The École Normale Supérieure, a Parisian teachers' college, enrolled Pasteur in 1843, when he studied under the guidance of French scientist Jean-Baptiste André Dumas. In 1845, Pasteur earned a master's degree in science before going on to earn a doctorate in physics. In 1847, he received a Ph.D. in science. A year following his appointment as physics teacher at the Lycée de Dijon, Pasteur accepted a position as chemical teacher at the Université de Strasbourg. The rector's daughter Marie Leroux was his bride on May 29, 1849. Only two of the couple's 5 children survived childhood. Molecular asymmetry. He was baffled by Éilhard Mitscherlich's discovery of tartrates and paratartrates in polarized light, which showed that tartrates rotated the plane of polarized light while paratartrates did not. Soon after graduating from the École Normale Supérieure, Pasteur was baffled by this discovery. They had similar chemical properties, which was rare. Pasteur observed that the tartrate crystals had asymmetric shapes that mirror their optical asymmetry. He discovered that crystalline paratartrate was made up of a right-handed combination of crystals. The crystals, on the other hand, showed right and left asymmetry when separated manually. That is to say, an optically inactive blend of right and left crystals was found. Optic activity showed molecular asymmetry, which was discovered by Pasteur and established stereochemistry. Pasteur's research on organic compounds' ability to spin the plane of polarized light continued over the next 10 years. He also looked at the relationship between the structure of crystals and the arrangement of molecules. There is asymmetry in living matter because of his research, which convinced him that it is fundamental. Fermentation in the presence of bacteria. A few years later, Pasteur was named professor of chemistry and dean of Lille's science faculty. To assist a local distillery with its production issues, while working in Lille, he began researching the process of alcoholic fermentation. As a result of his work on these issues, he became involved in a wide range of additional fermentation-related practical and economic issues. Most of these puzzles were successfully solved as a result of his efforts, and new theoretical implications were discovered as a result of them. Many elements of fermentation were studied by Pasteur, including the creation of lactic acid, which causes milk to sour. The fermentation of butyric acid was also a topic of interest to him. Having been named manager and head of scientific studies at the École Normale Supérieure, Pasteur went to Paris in 1857 after leaving Lille. In the same year, he gave experimental proof that living creatures are involved in all fermentative processes and that a specific organism is associated with each fermentation in particular. The germ theory of fermentation was born as a result of these findings. Pasteur Effect. Pasteur's experiments on butyric acid fermentation bolstered the idea that certain organisms were involved in fermentation. Following these experiments, Pasteur discovered the unanticipated phenomenon known as the Pasteur Effect, in which the fermentation process can be slowed down by flowing air, oxygen, through the fermenting solution. He came to the conclusion that the lack of oxygen was caused by the presence of a life form that could only function without it. To describe organisms that live in the presence or absence of oxygen, he coined the terms aerobic and anaerobic. He also proposed that putrefaction was caused by anaerobic functioning germs, which he attributed to the observed observations. Pasteurization. Pasteur immediately adapted his knowledge of germs and fermentation to the French wine and beer industries, sparing them from collapse owing to production and export contamination problems. Pasteur examined wine contamination in 1863 at Napoleon III's request and found that bacteria were to blame. A simple approach was performed by Pasteur to ensure the safety of the wine. He heated it to between 50 and 60 degrees Celsius, 120 and 140 degrees Fahrenheit. Pasteurization, which destroys the organisms that contribute to the aging process, is rarely employed nowadays for wines that benefit from aging, although it is widely utilized in the food and beverage industry, particularly for milk. Pasteur turned his attention to beer after his success with wine. He was able to establish a rational framework for the brewing industry by developing effective procedures for controlling beer fermentation. He also came up with a way to keep beer fresh for lengthy periods of time on ships by developing a process for making spontaneous generation. Fermentation and putrefaction were once thought to be spontaneous processes, based on the old concept that life might arise out of thin air. The English naturalist John d'Urberville Needham and the French scientist Georges Louis de Buffon, Count of Buffon, were involved in the debates of the 18th century. The Italian monk and physiologist Lazzaro Spallanzani disagreed on the issue of spontaneous creation, believing that life could never arise from lifeless substance. Pasteur resolved to settle this controversy in 1859, the year Charles Darwin published On the Origin of Species. As long as people believed in spontaneous generation, he believed his germ theory couldn't be proven to be correct. Pasteur used a simple experiment to solve the problem. A swan neck flask, which has a long, bending neck that collects dust and other impurities before they reach the flask's body, was used to sterilize beef broth. However, when the soup was boiled and the flask's neck was torn off after boiling, the broth became turbid and showed signs of microbial contamination due to the re-exposure to air. No spontaneous generation was found in these studies, as boiling broth did not degenerate when not exposed to air again. There were no more philosophical questions about how life began, and bacteriology, which relied on proven techniques for sterilizing and aseptic manipulation, was established on solid basis as a result. Silkworms. Following Pasteur's election to the Académie des Sciences in 1862, the École des Beaux-Arts named him professor of geology, physics, and chemistry, School of Fine Arts. Pasteur's focus shifted to the silkworm situation in France not long after. An unknown disease ravaged French silkworm nurseries in the middle of the 19th century. Due to the disease's spread throughout Europe and Eurasia, including the Caucasus area, China, and Japan, silkworm eggs could no longer be produced in France or imported. By 1865, the silkworm industry in France and the rest of Western Europe had all but vanished. The desire of his former master Dumas prompted Pasteur to accept the challenge and seize the opportunity to learn more about infectious diseases. He knew nothing about silkworms. One of the first people to identify the microbes that cause silkworm sickness became an expert silkworm breeder. A method that enabled the preservation of healthy silkworm eggs and prevented their contamination by disease-causing organisms was developed by him after 5 years of research. Once this procedure was widely accepted in Europe within a few years, it is still used today in silk-producing countries. Prior to his appointment at the Sorbonne in 1867, Pasteur had served as an administrator at the École Normale Supérieure, also known as the Normal Supérieur. However, he continued his research even after he was rendered partially paralyzed in 1868, by left hemiplegia. As a result of his work on silkworms, Louis Pasteur first learned about the intricacies of infectious illness transmission and development. After seeing how silkworms differed in their response to sickness based on their physiological and environmental conditions, he was surprised to learn that animals are not as predictable as laboratory methods. Pasteur's investigations into these issues led to the development of epidemiology techniques that he later applied to the study of animal and human disease. Work on vaccine. In 1873, Pasteur was elected an associate member of the Académie de Médecine, a position he held until his death in 1925. Medical professionals were hesitant to accept his germ hypothesis of disease, in part because it came from a chemical scientist. However, in the following decade, Pasteur contributed to the basis of immunology by developing the overarching principle of vaccination. A disease known as chicken cholera was the focus of Pasteur's first significant discovery in the field of immunization in 1879. Pasteurella is the genus of bacteria that cause the sickness today. Pasteur remarked, "Chance only favors the prepared mind, and he discovered that chicken cholera cultures lost their virulence and kept attenuated pathogenic properties over the course of many generations through a chance observation. Chickens implanted with the attenuated strain were found to be resistant to the fully virulent strain of the disease. Pasteur subsequently devoted the rest of his scientific career to figuring out how to prevent sickness through vaccine. In 1879, Pasteur began researching anthrax. Anthrax had killed a considerable number of sheep in France and other European countries at the time, and the sickness was affecting humans as well. The Anthrax Bacillus was discovered by German physician Robert Koch, and Pasteur confirmed it. Both Koch and Pasteur proved conclusively that the Anthrax Bacillus was the source of the infection through their own experiments. Medical microbiology was founded on the germ theory of disease after this. For Pasteur, anthrax was a disease that could benefit from the vaccine method. After figuring out what caused the bacillus to lose its virulence, he created attenuated cultures of it. Anthrax immunization experiments were conducted on a big scale in the spring of 1881, largely funded by farmers. Pailly-le-Fort, a suburb of Paris to the south, was the site of the experiment. Pasteur successfully immunized 70 farm animals in his experiment. Vaccines of varying potency were administered at intervals of 12 days during the vaccination phase. A low-virulence vaccination was administered to half of the sheep, and a more virulent vaccine was given to the other half. Vaccinated and unvaccinated sheep were infected with a virulent strain of anthrax 2 weeks after the first inoculations. All of the control sheep perished within a few days, however all of the vaccinated animals were unaffected. Many people were persuaded by this that Pasteur's research was in fact sound. Pasteur turned his attention to the microorganisms that cause disease after the success of his anthrax immunization trial. He was a pioneer in infectious pathology because of his work on animals infected with pathogenic bacteria and his study of the microbial pathways that induce negative physiological consequences in animals. Many people believe that Edward Jenner, an English physician, made the discovery of vaccination, and Louis Pasteur, a French scientist, created vaccinations. The first vaccination against rabies was created over 90 years after Jenner began immunizing against smallpox. In 1882, the year he was accepted into the Académie Française, he decided to take on the rabies problem. Throughout history, people have been fascinated by the unknown origins of rabies and the fear it inflicts. Pasteur's final challenge would be to conquer it. After his death in 1896, scientists realized they had been wrong about Pasteur's theory that rabies is caused by some sort of germ. The sickness was too small to be seen under Pasteur's microscope, therefore other methods had to be devised to study it. During his trials with rabbits, Pasteur used intracerebral inoculations to transfer the infectious material from animal to animal until he obtained a stable preparation. In order to reduce the virulence of the unseen agent, he dehydrated the spinal cords of animals infected with the disease. He discovered afterwards that his treatment had neutralized the agent rather than weakening it. As Pasteur assumed the agent was a live thing, he interpreted the neutralizing action as a killing one. As a result, rather than attenuated living microbes, he had created a neutralized agent, which opened the door to the invention of inactivated vaccinations. Joseph Meister, a 9-year-old boy who had been bitten by a rabid dog, was vaccinated by Pasteur on July 6, 1885. Pasteur was immediately hailed as a hero after the vaccine's effectiveness. Pasteur's vaccine rescued hundreds of morbid victims around the world, and the era of preventative medicine had begun. The Pasteur Institute in Paris was inaugurated on November 14, 1888, thanks to a massive international fundraising effort. Significance of Pasteur's research. Pasteur's work had enormous theoretical and practical implications. Pasteur once observed, "Knowledge and the application of science are the only things that exist, there are no pure and applied sciences." In other words, he looked for ways to further develop practical applications after first establishing the theoretical underpinning for a specific procedure. Because of this, he filed several patents. Pasteur, on the other hand, lacked the time and resources to fully study all of the practical implications of his many hypotheses. As a result of his vaccine attenuation studies, he came to the critical theoretical conclusion that virulence is not a continuous quality, but a variable property, one that can be lost and subsequently restored. At one time Pasteur believed that virulence could be reduced, but now he believes that it can really be increased. Epidemics, according to him, are the result of an organism's heightened pathogenicity. Pasteur was quoted in Louis Pasteur, The Free Lance of Science, 1950, by American microbiologist René Dubos. Thus, virulence appears in a new light which may be disturbing for the future of humanity unless nature, in its long evolution, has already had the occasions to produce all possible contagious diseases, a very unlikely assumption. What is a microorganism that is innocuous to man or to a given animal species? It is a living being which does not possess the capacity to multiply in our body or in the body of the animal. But nothing proves that if the same microorganism should chance to come into contact with some other of the thousands of animal species in the creation, it might invade it and render it sick. Its virulence might increase by repeated passages through that species, and might eventually affect man or domesticated animals. Thus might be brought about a new virulence and new contagions. I am much inclined to believe that such mechanisms would explain how smallpox, syphilis, plague, yellow fever, etc. have come about in the course of time, and how certain great epidemics appear once in a while. Pasteur was the first to discover that virulence might vary from one strain to another. Understanding the emergence of diseases such as bovine spongiform encephalopathy, BSE, severe acute respiratory syndrome, SARS, and acquired immunodeficiency syndrome, AIDS, is still essential to the study of infectious disease, AIDS. Despite the fact that Pasteur celebrated his 70th birthday at the Sorbonne with a huge but solemn gathering that included a number of notable scientists, including British surgeon Joseph Lister, his health deteriorated further. At the end of 1895, he died of paralysis. Remains from the Cathedral of Notre Dame de Paris were moved to the Pasteur Institute's Neo-Byzantine crypt in 1896, where they remain today. When describing Pasteur's accomplishments, it's impossible to convey the breadth and depth of his life's experiences. When he was convinced that truth was on his side, he was infamous for his impatience and intolerance. He never accepted defeat and strove to persuade skeptics. Throughout his life, he was a superb observer who was quick to incorporate new information into existing mental frameworks. Thank you for listening in Audiobook Academy. Don't forget to subscribe and smash that like button for more content like this. See you in next video.